The essential question for this video is, what is a parabola? And we dealt with parabolas a lot last semester, but now we're going to be looking at parabolas in a different way. So let's take a look at this alternate definition of a parabola. A parabola is a set of all points which are the same distance from a given point, which we call a focus, and a given line called the directrix. So the set of all points which are the same distance from a given point and a given line. So take a look at our graph right here. Let's work with this. Now I've taken the liberty of already drawing a dashed line right here, right above the x-axis. So go ahead and use a straight edge, if you would, class, and draw a dashed line right here where y equals 1. So it's just above the x-axis. And let's label that. This is what we call our directrix. Our directrix. And now let's take a look. We're going to be labeling the next part, which is our focus. Let's go ahead and put a point on our graph and call it our focus. So we're going to count, let's see, 1, 2, 3, 4 units above the directrix. We'll use the y-axis. And I want you to go ahead and label that as the focus. Okay, so here's our directrix line, and here is our focus point. Let's go ahead and fill something out here to the right side of our graph. And that is this text. The vertex is exactly between the focus and directrix. So go ahead and write that in, fill in those blank lines with the words I gave you. The vertex is exactly between the focus and the directrix. You could call that the midpoint. It's right in between the focus and directrix. Let's go ahead and draw the vertex in. So if I know this is my focus for the parabola and this is my directrix, 1, 2, 3, 4, there's 4 units between those two things, so our vertex is going to be 2 units below the focus, or in this case 2 units above the directrix. So let's go ahead and label that. There is where our vertex is going to be. And the vertex will always be exactly between those two things, the focus and directrix. And then there's something else we're going to label here, and that is called the p-value. So right here in your descriptions as well, I want you to write this sentence. The p-value is the distance from the vertex to the focus. The p-value is the distance from the vertex to the focus. Let's go ahead and label that on our graph here. So I'm looking for a p-value that's right here, the distance between the focus and the vertex, and that is my p-value. Let's go ahead and, actually, you know what, I'm going to write that on the other side. This is going to be our p-value. You'll be hearing a lot about that as we deal with focuses and directrix. So p-value. So in this case, you can see on our graph the p-value is equal to 2. And then the p-value can be positive or negative. So over here in your text, I want you to write the word positive in capitals, and the p-value will be positive if our parabola faces up, and the p-value will be negative if our parabola faces down. Now you remember, that's the same rules we had for the a-value. When the a-value of a quadratic equation is positive, the parabola opens up, and when it's negative, the parabola opens down. And then let's take a look at how this definition will help us to draw an example parabola with this focus and this vertex and this directrix. It says the parabola is the set of all points which are the same distance from the focus and the directrix. So what I'm going to do is have you go ahead and sketch a parabola here, and here's the best way to do it is go to the focus class and you're going to go double the distance left and right, double the p-value left and right. So the p-value here is 2. Let's put that in parentheses so you see it's 2. And that means from the focus we're going to go 1, 2, 3, 4. 4 units over. This is actually labeled as, let's do this so you guys can see this. This is going to be 2 times the absolute value of p. We don't care if it's positive or negative at this point. Since our p value is 2, 2 times 2 is 4. And this orange point is always going to be on our sketch of our parabola. So when you sketch your parabola, you're going to see that that point is actually going to be on the parabola. And the same thing over here, 1, 2, 3, 4. I don't want to mess up our words, but you'll be able to see over here the parabola will also go through that point. And what we want to do is let's label one more thing on our parabola. It's the set of all points that are the same distance from the focus to the directrix, and that means if we pick any point on this parabola, let's pick one, then we know that our definition says that the distance between this point and our focus, I'm going to make that a little bit thinner, not that thin, is the same as the distance from that point straight up to our directrix. So if you draw these out, whoops, I didn't want that to show up. Can I get that to go away? Let's try one more time. And there we go. And you can mark on here that these two lines are going to be congruent. Any point on this parabola, if we measure from that point to the focus and then measure from that point down to the directrix, those distances will be exactly the same. That is our new definition of a parabola. We'll be using these things, focus, directrix, p-value, 2 times p. We'll be using those throughout this section on parabolas to draw parabolas based on a focus and a directrix.